we'll go through it here. So we have a proton in my lab. It accelerates uniformly from 5 times 10 to the 4th to 6 times 10 to the 6th meters per second. It's a huge acceleration, change in velocity, and it does all this in a very short amount of space, so 3 centimeters. The first question says, how many seconds does it take for this proton to travel those 3 centimeters? So being it accelerates uniformly, we can use our kinematic equations, okay, for our 1D motion or kinematic equations. So I'm going to go ahead and make a table and list down what I know. So I did that over here. I know that the change in x, it was given in centimeters. I don't like that. I'd rather everything be in SI units for clarity later, and we don't confuse our answer with some weird units. So I went ahead and changed that to 0.03 meters. Okay. The initial velocity, okay, it started from this, so 5 times 10 to the 4th is the initial. The final velocity is where it ended. 6 times 10 to the 6th is our final velocity. The acceleration wasn't given, didn't talk about it, but it did ask for the time. That was the first question. How many seconds does it take for the proton to travel? Okay. So t is what I'm looking for, hence the question marks. So I've got 3 out of the 5 things. That's perfect. That's all that I need. We'll solve for the 4th one, and we look for what we don't care about. So in this one, I don't care about the acceleration. Wasn't asked, wasn't given, doesn't matter. So I want to pick the kinematic equation that does not rely on acceleration, being I don't know anything about it. So if you look at your kinematic sheet and your equations, you get this equation that does not have acceleration in it. Okay, so this is the change in x is equal to 1/2 the 2 velocities added together multiplied by t. And now it's just a plug-in. All right, so the change in x we know, 0.03, equals to 1/2. The initial and the final velocities, put them in there, 5 times 10 to the 4th, 6 times 10 to the 6th, and we're going to multiply that by t, and t is what we're going to solve for. So to solve this, I would go ahead and I would figure out, being these are in brackets, I would go ahead and figure out what this is, 5 times 10 to the 4th plus 6 times 10 to the 6th, and get a number here. I'd multiply that number by 1/2, so I'd have a number times t. Okay? I would then get t by itself by dividing whatever this entire number is on both sides. Okay, and if we do that, we get that t here is equal to 9.8 times 10 to the negative 9th seconds. Okay, this is traveling very fast in a very small distance, so our answer here should make sense that it is a very, very quick transition in those 3 centimeters. So 9.8 times 10 to the negative 9th seconds. The second part of this says, what is the proton's acceleration during that time interval? Okay, so now we're looking for A. So there's a couple of ways you can do this, because now you also know t. If you're confident with your answer for t, you could pick any of the equations that involve A and solve out. Just know that you are using an answer that you previously got. Okay, there's nothing wrong with it as long as this answer is correct. Everything else will be fine. Another way to try and avoid this, if you don't feel confident in your answer, is to try and use what was given. You know that these numbers are correct because they came straight from the problem. So we can solve for A as long as we have these 3 other things. Okay. So to do that, I look for an equation that does not involve t, okay, which is one of the last equations. Vf squared is equal to Vi squared plus 2ax. No t involved in that, and it has everything we need. It's just going to be really big numbers. Okay, so Vf squared is going to be 6 times 10 to the 6th squared. Vi squared is going to be 5 times 10 to the 4th squared. Plus 2 times a. A is what we're looking for here, the acceleration. And then the change in x, 0.03. Okay, this one can get a little bit weird to put in because you're going to have a lot of parentheses if you put this into your calculator. Okay, so what I would do first is I have this addition here going on. I want to get rid of that. So I would minus this value, whatever it is, to the other side. So I'd have 6 times 10 to the negative 6 squared minus 5 times 10 to the 4th squared. Okay, over on this side. And that'll give you a number. Okay. Then we have 2 times a times the 0.03. Well, 2 times this is going to be 0.06. So then I would divide both sides by the 0.06. That will get rid of both of these and leave a all by itself. Okay. If you do it out correctly, you might have to look around, do it in your calculator. If you do it out correctly, you get 5.999 repeating. So I rounded it up to 6.0. times 10 to the 14